Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. For this video, we would like to present about the project presentation amplitude modulation AM transmission system. We are from Group 5 and Section 2. The lecturer name is Dr. Mariam Jamilah binti Hamam. For this project, we are consist 5 team members. Firstly, me, Ajmal Danish bin Muhammad Zimri, CE 210217. Second, Ahmad Solihin bin Azlan. The matrix number is AE 210030. And next, Muhammad Nizam bin Zahari. The matrix number is CE 210005. And fourth, Abdul Hasib bin Abdul Rahman. The matrix number is AE 210026. And the lastly team members is Ahmad Shakir Iman bin Muhammad. The matrix number is AE 210029. Next, go to the introduction. For the introduction, we have a project background for this project. Okay, electronic communication involves the transmission, receiving and processing information using electronic circuit. The fundamental component of an electronic communication system include the transmitter, communication channel, receiver and noise. AM transmitter, also known as amplitude modulation transmitter, transmit data using amplitude modulation AM. They are essential for conventional radio transmission, transmitting audio program, information and various material over medium wave and short wave band. And next, AM transmitter have two types, which is high level and low level. High level AM transmitter modulate a circuit with a high power section, while the low level AM transmitter use a low power stage and require power amplifier to increase the signal. AM transmitter remain essential in various applications, providing a reliable and cost-effective way to send audio material across a large distance. Next, the introduction, we also have a filler table. So, the filler table we do before we run a project. It is because we need to know what the fact, idea, planning, issue and action about the AM transmitter. So, filler table is important before we do we construct the AM transmitter circuit. Next, we go to the circuit design and description. So, for this project, before we construct a AM transmitter, we need to have a circuit and the block diagram. So, the left picture, as we can see, this is the simulation circuit diagram, and the right picture, we have a block diagram for this project. And lastly, for the middle picture, we have a hardware circuit diagram for this project.
Next, for the circuit description, this project involves design a single transistor complete oscillator circuit for an AM transmitter. The circuit consists of a single transistor and a turned circuit, and that generate a single frequency RF signal. The RF signal is transmitted into the A through the antenna coupling. The circuit starts from transistor Q1 and operates at the desired frequency. The AM transmitter circuit is intended to operate at the frequency of around 1 MHz, but cannot transmit AM radio transmission. However, it can transmit audio signal like music or data message. To transmit audio signal, an audio amplifier is added to modulate the RF signal, which is then modulated into the RF signal. To send data signal, a data modulator is added to modulate the RF signal, which is then sent via the antenna. Next, for block description, wireless audio transmission involves several phases, start with an audio jack that converts sound wave into electrical signal. An audio driver amplifier amplify the initial audio stream, followed by modulate class C power amplifier to ensure strength. A carrier oscillator generate a high frequency carrier signal at the specific transmission frequency, which is amplified by the buffer amplifier and a frequency multiplier. The frequency modulator carrier signal is amplified by a power amplifier to achieve the required strength. for operate with a transmitting antenna. The modulated carrier signal is amplified functioned by a modulated Class C power amplifier for effective transmission through the transmitting antenna. Next, for the system description, the audio signal transmission involves a schematic approach of signal amplification, modulation, and transmission. The audio jack signal is amplified through the two stages, the audio driver amplifier and the audio power amplifier. The carrier signal generated by the carrier oscillator follow its own routes, going through buffer amplifier and frequency multiplication. The audio and carrier signal combine with a modulated Class C power amplifier, resulting in a modulated carrier signal. The signal contain encoded information and serves as the foundation for transmitting data. The modulated Class C power amplifier boosts the signal strength to drive the transmitting antenna, ensuring it can withstand transmission over desired distance and medium. The transmitting antenna acts as the gateway, sending the modulated carrier signal to travel through the A wave and transmit the encoded data across the intended communication channel. Next, for input analysis, the AM transmitter circuit uses an audio signal like music for a telephone to generate an input signal. The signal is analyzed using an oscilloscope connected to the audio jack socket. The analyzed signal is a full tone with a frequency of 2.14 kHz and a small peak-to-peak amplitude of 4.4 mV. The frequency comes from the telephone line output, which is lower than human speech. The waveform displays the form before the modulate procedure, representing the outcome in the way as the input waveform. The AM transmitter found that the input signal performed in the 50 Hz to 5K kHz range.
Assalamualaikum, my name is Ahmad Solehin bin Azlan. So I will explain about the subsystem output analysis of our project. So in the context of an AM transmitter, the carrier signal, which is an unmodulated radio frequency waveform, is produced by a carrier oscillator, and its frequency is achieved through multiplication of a submultiple frequency. The modulation depth or modulation index of this carrier signal is a critical parameter as it signifies the extent of amplitude change, playing an important role in ensuring efficient transmission and reception. Based on our result in the oscilloscope reading figure below, the carrier signal of our AM transmitter well functions as it suits the required frequency to transport the modulated data.
Assalamualaikum, my name is Ahmad Syakriman bin Muhammad. My matric number is AE210029. Today, I want to present our output analysis. Figure shows the output signal for our AM transmitter during testing using an oscilloscope at the lab. The signal was produced after an audio signal combined with a carrier wave to create the amplitude modulated signal, which is AM signal. The amplitude of the carrier wave changes in proportion to the instantaneous amplitude of the audio signal. The AM signal is then fed into the transmitter power amplifier, which amplifies the signal to an appropriate level for transmission and then sent to the antenna, which radiates the signal into space for reception by AM receiver, which is we use AM radio. For our AM transmitter, we managed to get a frequency of 1.49 MHz, which is in range of targeted frequency, which is 500 kHz until 1.6 MHz. This frequency is higher than audio signals because the audio signal was modulated with carrier signal. Other than that, our AM transmitter amplitude is 23.40 millivolt peak to peak. This amplitude is higher than audio signal because it was modulated by carrier signal. This signal also can be received by AM receiver and AM radio for more than 1 meter away.
For the discussion part, firstly we're going to talk about input analysis. So the input signal waveform in figure 4 shows a nearly sinusoidal wave indicating a modulating signal from the audio signal. The oscilloscope displays a frequency of 2.14 kHz and a peak-to-peak amplitude of 4.40 mV, typical for AM transmitter. The analysis focuses on the modulating signal's frequency and amplitude, indicating the AM transmitter can effectively modulate the carrier wave and produce a clear audio signal. Second is for the subsystem output analysis. So figure 5 reveals a sinusoidal waveform as a carrier signal with a frequency of 895.27 Hz and a peak-to-peak amplitude of 5 to 8 mV. The carrier signal is an unmodulated radio frequency waveform that transports modulated data, with the frequency being a crucial parameter. The carrier oscillator produces a submultiple frequency to obtain the required carrier frequency. And for the last part for the discussion is the final output analysis. The final output signal waveform, a modulated sine wave, indicates an audio signal on the carrier wave. It has a fundamental frequency of 1.49 MHz and a peak-to-peak amplitude of 23.4 mV. The waveform is clean and shows minimal noise or interference. The carrier frequency discrepancy possible due to a misconfiguration is not significant. The waveform demonstrates successful modulation of the carrier wave with the audio signal, indicating the transmitter potential to transmit modulated AM signal. And lastly, for the conclusion, so throughout this whole project, we are able to build and create an AM transmitter that can transmit data with a limited coverage area. This project highlights the importance of core components like oscillators, modulators, amplifiers, and antennas in AM transmitter. By understanding this component, we have successfully created a transmitter design and construction. The project distinguishes between high-level and low-level AM transmitter, emphasizing the difference in modulation technique and power output. Thus, with this knowledge, it helps us to choose the appropriate transmitter type based on specific requirement. We can acknowledge the continued relevance of AM transmitter despite the emergence of alternative modulation methods like FM. We can also highlight the advantage of AM in terms of reliability and suitability for certain applications. Overall, the project emphasized the potential of developing a community radio station using an AM transmitter, contributing to local communication and information dissemination. I think that's all from our group. Thank you.